let's remember back to geometry. In geometry, we had a couple triangles. They don't look alike. We have a couple triangles. This side was congruent to this side, this side was congruent to this side, and this angle was congruent to this angle. What do we call it? Side angle side. If side angle side was the same for two triangles and the triangles were congruent. Okay? We had side, side, side. We had angle, angle, side, angle, angle, side. But in geometry, if you can remember that far back, let's try this again. I didn't mean to delete those. What's this one? Angle side side. If you try to use angle side side, it made an angle side side of you, right? You guys remember that from geometry back then? Yeah. You don't ever say angle side side, you angle side side. You donkey, you. We could use side side angle because when you have side side angle, this is what happens. It might look like that, or oh, that's not a very good representation. Or it could look like that. If this was 10, this was 9, and this was like 46 degrees, this could be 10, 9, and 46, but are those congruent triangles? No. That's why we can't use side-side angle. Okay? Because you could have two different triangles. Now, today, we're going to look at the law of sines and how sometimes we'll have two triangles. And sometimes we'll have no triangles. If this is like 14 and this is like 6 and this is like 50 degrees, what happens is this is just dangling down here and it's never going to touch that. So if you got a dangle and it doesn't touch, then you have no triangle because a dangle doesn't make a triangle. All right. So let's start with this. Okay. When you do this, follow my directions. We're going to make an acute triangle and an obtuse triangle. The acute triangle, whatever angle they give you, put down in this lower left-hand corner of each of them. That's alpha. Now, what side is opposite of alpha? A is opposite of alpha. They're the same letter. So 3.6 would be here, 3.6 would be here. The other side that you're given, put right here, 7.5. Okay? So 7.5 is C, so this is gamma here. In both the triangles, it's going to be gamma, because C is opposite of gamma. So beta is here, and B is here. Beta is here, B is here. Now, we got to see if this works. Okay? So, we're going to do the law of sines to do opposites. We have opposites there. I want an opposite there. So we'll go the sine of 35 degrees over its opposite side, 3.6, equals the sine of 7.5 over its opposite side, gamma. Or sine of gamma over its opposite side of 7.5. There we go. Whew, about screwed that up. So take this times this divided by this. And you get some decimal, right? 7.5 times the sine of 35. I don't know what that is. And divided by 3.6. What do you get when you do that? The sine of y equals what? What's 7.5 times sine of 35 divided by 3.6? 1.2. Take the inverse sine of 1.2. What do you get? You get an error, right? Can't do it, can you? So what is this? Well, this is an example of a dangle. This is too short to hit this side. So it's really one of these, where it's just hanging in the wind. It's too short. Does it ever make a triangle? No. There are no possible solutions when you have a dangle. A dangle is going to be no possible solutions. All right, let's do the next one. What do you draw? Well, you draw a good-looking triangle and a cute triangle. And you draw an obtuse triangle. Okay, got my cute, got my obtuse. We don't put the letters on right away. Don't label it A, B, and C. Because compared to up here, it went A, B, C this way. But down here, whoops. But down here, it's not going to be labeled the same. Now we're given A as our angle this time again. So A will be there, 8.7 will be there. B will actually be right here, so that means beta is here. So 43.2 is here, 8.7 is here, 10.5 is here. Now, I don't think this one will be a dangle, because 10.5 and 8.7 are fairly close to each other. Up on the first one, we had, I forget what we had. On the first one, we had 7.5, 3.6. They're a long ways apart, which made it have a dangle. But we're not going to have a dangle here. Okay? So, what do we do? Well, we do the law of sines, and I want to figure out beta. Okay? Because I have B, I have A, I don't have gamma, and I don't have C. So, the sine of 43.2 over its opposite side, 8.7, equals the sine of beta over its opposite side, 10.5. So take 10.5 times sine of 43.2, get a number, divide by 8.7, give a number. What does the sine of B equal? Give me 4 decimal places. 0. What? 8262. And then we move the sign to the other side, so it's the inverse sign of the answer. How big is angle B? 55.7. Or is it 55.7? Dun, dun, dun. This is the ambiguous case about it. What I want you to do is take 180 minus 55.7. Give me that number. 124.3. Take the sine of 124.3 once. I bet you get 0.8262. On your calculators, take the sine of 55.7. And you get 0.8262, right? You get the exact same number. So when you take the inverse sine of 0.8262, is it 55.7 or is it 124.3? which one is it? We don't know. That's why it's ambiguous. Something that we really don't know is ambiguous. Ooh, is this English class or is this trig class? Because I just taught you a word, ambiguous. Now, some of you obviously knew what ambiguous was before, but this is a good way to remember ambiguous is something we really don't know. It's really not clear. Okay? So that's why we draw two triangles, and that's why we have two answers, because we don't know for sure what that angle is. Okay? So we solve both of them. So we take 180 minus this, what would that be? So we're going to use our calculators lots today. Every problem will be calculator. 180 minus 43.2 minus 55.7 should be 81.1. Okay? So gamma could be 81.1, or over here, if we take 180 minus 43.2 minus 124.3, gamma could be something else. 12.5. All right. So we know all the angles. Now we just need to know one more side. So this was given to me, this was given to me. So I'll use these two. So I'll say the sine of 43.2 over its opposite side, 8.7, equals the sine of 81.1 over its opposite side, x. So take 8.7 times the sine of 81.1, press equals, divided by the sine of 43.2, press equals, and you get C. And C should be bigger than 10.5. What do we get for C? What? 12.6? Sounds good to me. Now you're going to do the same thing over here, but with different numbers. The sine of 43.2 over 8.7 equals the sine of 12.5 over C. Opposites, because C is down here. Okay? So 8.7 times sine of 12.5, press equals, divided by the sine of 43.2, press equals. C is some small number, smaller than 8.7. What? 2.8. So this is how you fill in the answer blanks. Okay? Your first row, because there's two triangles here, so it's going to be this one, 2. Your first row answer blanks. Okay? Your first row will be the acute triangle. Okay? So angle B was 55.7. Angle gamma was 81.1. And side C was 12.6. And then the other one will be your obtuse triangle. Angle B was 124.3. Angle Y was 12.5. Or gamma was 12.5. And C was 2.8. Ta-da. All right. Next. Before I start this problem, I see I have an obtuse angle. How many obtuse angles can I have in a triangle? 1. So how many triangles are there going to be? At most, 1. So instead of drawing 2 triangles for this one, once I see an obtuse angle, I'm going to go, well, I got an obtuse triangle here with a 140.6 here. Now, that's B. Opposite of B is 15.6. And then some other side is 8.6. which is C, which is opposite of gamma. So alpha will be up here, and A will be down here. And I solve away. Now, because I already have one obtuse angle, I just can do the law of sines and figure it out, just like we did the other day. Sine of 140.6 over 15.6 equals sine of gamma over 8.6. Cross multiply and solve. Take this times this divided by this, and then do inverse sine of your answer. So gamma equals how much? You will get an answer for this one. It does work. What do we get? Small number. Not super small number, but should work. What? 20.5. That's my angle. Now, how many degrees are in a triangle? In a triangle, there's 180 degrees. This is 161.1. So this would be 18.9, right? And then, one more time. Sine of 140.6 over its opposite side, 15.6, equals the sine of 18.9 over its opposite side, A. So alpha is 18.9. Gamma is 20.5. A is whatever you get when you do the law of sines there. We can do that, right? Right. All right. Here's another one with an obtuse angle at the start. So you draw an obtuse triangle. You go 157.5. Opposite of that is 6.6. Some other side is 9.2. So that's A's and Y. So this is alpha here, beta here, B here. So if we go sine of 157.5 over 6.6 equals the sine of alpha over 9.2. Take 9.2 times sine of 157.5 divided by 6.6. Hit inverse sine of your answer. And what do you get? What do you get as an answer? No, you don't. Take 9.2 times the sine of 157.5 divided by 6.6 and hit inverse sine of your answer. 32.2. Oh. Yeah. Okay, so you get 32.2. So what's left for angle B? 180 minus 32.2 minus 157.5. What do you get? A negative number. Can you have a negative angle? No. If you look at these two add up to more than 180. Will that work? No. Remember from geometry, the biggest angle is opposite the longest side. Is the biggest angle opposite the longest side? No. So when you first draw out this triangle, if you see big angle, not the longest side, what do you know right at the start? Not a triangle. No solution. Okay. So this next one works, so we're going to do one more. and then I'll let you get going on this. So this one, because you need to know how to do this, because your quiz will have this on it, because your test will have this on it, because your semester test will have this on it, you need to know how to draw two triangles. One acute, one obtuse. Okay? Whatever angle they give you, lower left-hand corner, just don't randomize where you put it. Lower left-hand corner of each. Beta is opposite of B. So if this is beta, B is opposite of it, 32.2. And this is 37.4. 32.2 is close to 37.4, so I don't think this one will be a dangle. Okay, but we always got to check. How do we check? Well, we start doing law of sines. All right, so if this is A, alpha must be here. That makes gamma up here. Will gamma always be at the top? Nope, it won't. You don't label your triangles until you get the numbers in. Then you can start labeling. All right, so opposites. The sine of our angle, 35.7, over its opposite side, 32.2, equals the sine of alpha over its opposite side, 37.4. So 37.4 times the sine of 35.7, press equals, divided by 32.2, press equals. Do inverse sine of the answer. And then you can figure out what alpha is. 46.7. Are we sure it's 46.7? No, that's the angle where we have an acute and an obtuse. So how do we find the obtuse? Well, you take 180 minus 46.7. So if you take 180 minus 46.7, what do we get? 133.3. Okay. Now, what we do is we take 180 minus these two to get angle gamma. So 35.7 plus 46.7 is 82.4, which leaves us with 97.6. Am I right? Okay, I don't hear anybody arguing with me, so must be right. This is 169, so this is 11 up here. And you just do law of sines to figure out the other sides. So the sine of 35.7 over 32.2 equals the sine of 97.6 over C. And you find C. And then over here you do the sine of 35.7 over 32.2 equals the sine of 11 over C. And do law of sines, figure out C, and you find the answers. Okay? So law of sines, ambiguous case. It takes a little bit more to do this. Okay? So get to work, please. I will put it out there.